the line segment x equals 1 minus y, where y is between 0 and 1, is revolved around the y-axis to generate a cone. Find the lateral surface area which excludes the base area. First, we graph the curve x equals 1 minus y. The y-intercept is 1 and the x-intercept is 1. We only need the part of the graph where y is between 0 and 1. We then rotate the line segment about the y-axis to form a surface, and we're looking for the area of the surface of revolution, which is the definite integral 2 pi times the radius times the arc length, with the lower limit of integration c and the upper limit of integration d, because we anticipate that the variable of integration is y. We rotate the curve about the y-axis, so the radius is x. The function given is x equals g of y. dx dy is therefore minus 1, because x equals 1 minus y. dx over dy squared is minus 1 squared, or 1. 1 plus dx over dy squared is 1 plus 1, or 2. Using the formula for the surface area, the integral from y equal to 0 to y equals 1, 2 pi times the radius, which is x, times the arc length, which is the square root of 2 dy. This is 2 pi times, in terms of y, x is 1 minus y. Simplifying this, we have 2 root 2 pi, the integral from 0 to 1 of 1 minus y dy, which is 2 root 2 pi times the entire derivative of 1 minus y, which is y minus 1 half y squared. Evaluate the entire derivative at y equals 0 and y equals 1. We obtain 2 root 2 pi times 1 minus 1 half minus 0, which is 2 root 2 pi times 1 half, or root 2 times pi. This is the exact area of the surface of revolution if we were to rotate the line segment x equals 1 minus y about the y-axis. The result is a cone with the slanted side L equals the square root of 2. We could have obtained the surface area. The area of the cone is pi r L. In this case, the radius of the base is 1 and L is root 2, so the area of the cone is pi times 1 times root 2, which is root 2 pi, as expected.